I'm Mario Russo. I'm a researcher to Leonardo and the University of Modena, and I generally studied impact-resistant and lightweight material through simulation, so a kind of digital twin. Next page, go. Thanks. You had to move the. Okay, thanks. The presentation will be very fast. There will be the introduction, the material selection that we made, the case study. I want to show you two different kind of research that I bring on, the application and the future investigation. Next page, thanks. Here you are. When you want to create some new materials, you have to select, of course, the material that you want to study and simulate it in different softwares. So you can see only the most used one, from the ANSYS to the Abacus in the source system. In my research, I focused especially in OptiStruct and Radios. That belong to this software ASIS that is Altair. Radios is used for explicit problem and Radios for implicit. The difference is that explicit problem are problem dynamics, so very fast, like impact. Can you go on? Thanks.
Whoop. I put two,
okay,
sorry.
no, don't worry. This is I refer to a famous book and film, Fantastic Material and Where to Find Them. It was called the Fantastic Animal and Where to Find Them. You can go next. In the field of research, move the arrow. Okay, thanks. In the field of research, there are a lot of different kind of new material that are being studying. One of the most interesting about impact problem in specific in ballistic one, there are the spiderweb. Spiderweb are created by the spider that are like real engineers. They create this kind of structure able to absorb the major part of the impact energy. In fact, if you think the spiderweb are designed to capture the flying during their flying. In this case, you can see an imaging of a 3D printing blue spiderweb that I generated in artificial intelligence. This kind of imaging is possible to reproduce in a 3D model, and the 3D model can be studied. And I've been studying about spiderweb for impact. Can you go on? Another interesting thing is other kind of composite material. One of it is mosaic. It's a composite material of molybdenum, silicium boron, and titanium carbide, and it was called adamantio. Adamantio is the alloy of that covered the skeleton of Wolverine. It was called in this way because it's very resistant, especially if it work on high temperature, about 160 degrees Celsius. You can go on. And another interesting material is vibranium. Vibranium is referred to the fantastic alloy of the Marvel cinema universe. The vibranium is the material that covered the costume of Black Panther, and it's able to absorb this kind of energy. In these few years, some researcher has created a material similar to vibranium that is more lightweight than aluminum, but more resistant, and they called it vibranium. Some children create a new element on the periodic table. You can see they imagine the position of this kind of material in this kind of Mendel tables, and you can see its representation as a chemical element. You can go on. Okay.
Sorry.
No, don't worry. we can enter in the study of real cases. So one of it is the plug drop composite. The problem born from the fact that the airplane land or take on flight, there are a little of debris on the streets that are dropped on the under the cargo of the airplane. So it was very important to create some material that are more resistant. You can go on. This is the bottom part where different debris are pulling out from the wheels. You can go on. Okay. So the solution was to create a kind of play drop. Allora, when we talk about composite, we have to think about different kind of material put in together. In general, in the aerospace, this kind of material are made like lamina, and the lamina are made of different layers. In this layer, it's possible to create some empty zone that are covered of resin, of course. The empty zone is represented by the triangle, and this kind of empty zone is able to stop the crack propagation. So you can go on a bit. Okay, thank you. This is a kind of model that you can use in the simulation to understand how it's possible to create this kind of material. You can see the different layer and the empty zone model that's an empty zone. You can go on. Okay. This is a normal generic model of an impact. You can see the composite material that is fixed on the edges and the impactor. In general, it's a spherical or semi-spherical body that impact the composite material, and it is made to understand these mechanical properties, especially resistance. You can go on. Okay, this is the final model and part of the pre-process before the simulation. You can go on. And this is the simulation part when you can see the different results. You can see the diagram of the different energy involved in the impact. To be fast, when you talk about impact, it's very important to understand the kinetic and internal energy of the material, and the summary of this kind of energy are the total one. When the simulation is okay, you have the so-called hourglass energy, an energy related to the software that is zero when the simulation is going on. You can go on. Thank you. The other case study is the bird strike on a composite leading edge. You can see different cases, dangerous cases that real happen. The last one is very famous because it was the inspiration of a film with Tom Hanks called The Sully, where the pilot was able to save people due to this kind of problem. And bird strike is one of the most dangerous frequent problem in aviation, and it happened when some birds impact on the wings of the planes. You can go on. Thanks. Here you are how to model this kind of problem. In general, there are four kind of techniques. It depends of the different meshes that you use and different results that you want to obtain. In general, there are Lagrangian, Eulerian, a coupled Lagrangian Eulerian method. But the most used, especially nowadays, is the SPC. SPC is smooth particle hydrodynamics. In this kind of simulation, the body is modeled like some different particle, and it impact the component in that case a leading edge. So the part that is on the wing of the airplane. You can go on. Yeah, this is a normal structure of the composite of the horizontal stabilizer of a plane. You can go circled in red the leading edge one, and you can see in this kind of imaging the result of a bird impact on the leading edge made up of aluminum and SPP. SPP is a kind of composite material that we want to use to substitute the aluminum. It's very interesting because it has a great property, especially when it's impacted. And the interesting thing is it's a material sustainable and lightweight. You can go on. Okay, the application of this kind of research, this kind of material is very wide, from the aerospace to energy to the urban air mobility, because in nowadays urban air mobility is been developing. Urban air mobility is about this kind of eVTOL, so like cars that are able to fly. You can go on. Okay, further investigation. The idea is to create with the artificial intelligence some biomimetic-inspired structure. Biomimetics is the discipline that is inspired by nature, and of course, so when you create this kind of structure, it's necessary to use additive manufacturing because are very complex. You can go on. These are some practical examples. There are two concepts made in artificial intelligence and inspired by nature. The first one is a wing of a dragonfly. It was optimized concerning the diagram of structure. And the other one is a 3D printing inspired car. It was inspired by turtles, and it's possible to create this kind of structure only with additive manufacturing. You can go on. Thank you. You have,